Sheet number 1, problem number 5. As we mentioned in the video or in the tutorial previous, that number 5 has a little bit tricky. We can read it to understand the tricky what is it. A wall is constructed of a section stainless steel K equal 16 and 4 millimeters thickness, with two identical layers of plastic on both sides of the steel. So that means that the wall, it will be in the middle and it will be identical plastic from the right and the left. Okay, considering that the convection on both sides of the plastic is 120. So the H here for the plastic is convection, it is 120. If overall temperature difference across the arrangement, for this arrangement overall, delta T equals 60. Calculate the temperature difference across the stainless steel. For this arrangement, delta T is 60. He wants us to calculate the temperature difference in this part through the stainless steel. So we have to know that the Q conduction equal Q convection. Q conduction equal Q convection. We will write here that the Q convection is equal Q HA delta T, and the Q conduction equal delta T over R total. Then the resistance here, it is R in series, so there will be the R total equal R1 plus R2 R3, but the equations are different because there is resistance convection and resistance conduction. So the first equation we will use that the Q equal H del A delta T for the convection. Here the area it is not given, so therefore we will assume that the area equal 1. Therefore we will make direct substitution, H equal 120 times 60 the temperature difference. Therefore Q convection equals 7,200 watts. For the other Q conduction, delta T, which is required over R2 R2. And the conduction, so R conduction is what? X over Ka. X is 4 millimeters, therefore it is multiplied by 10 power negative 3 times 16 A, and the area, we make assumption that the area equal 1. Therefore this will be the R conduction. If we make direct substitution in the Q equal delta T over R, the Q here is, we take here the Q from the equation calculated above, that as we said that Q equal Q conduction equal Q convection, and we make direct substitution, we will calculate that delta T equal 18 degrees Celsius. The last problem that we will have through the sheet is number 7, and it is little bit has a small trick, which is find the heat transfer per unit area through the composite wall in the figure. So we have here a figure. This figure is a composite wall. We can draw it together. We have a wall here. This is A, B. He said assume one-dimensional heat flow, and he given here in the drawing the area for C. AC is given here. One-dimensional heat flow, that means that all the parameters, all the composites, all the walls have the same area. So this area equal this area equal this area equal this area, and AC is given here, it is 0.1. Therefore area for the part A equal 0.1, like A, and the area for AB and AD, this is two equal parts, is given 0.1. Therefore AB equal 0.05. That these two parts are the same, so we divided by 2. And here the composite, this is and this resistance are in series or in parallel. We'll find here this part is in parallel and those are in series, so we calculate this to put it RBD, so all to be in series. And it's all conduction. What is here? This is only the trick. This is the tricky here. It's only how to calculate the area and how to change from parallel to series. And it's the required the heat transfer per unit area. To make it easier, it is the required the Q, because the area here is given. All is very easy. We will make direct substitution to calculate RA and RC and RB. So again, we will repeat that this problem, the only trick that you understand the assume one-dimensional heat flow means that the all walls has the same area, one dimension, that the flow goes through one dimension. One dimension means equal dimensional flow, so therefore the areas are the same, and you will find the areas given in the drawing. And the x is also the thickness is given here, and you find it is given in centimeters, so you have to change it to meter. And the other tricky part that you have to understand that this area B and D are equal to each other, so therefore the total area is divided by 2 to get it. That's all. Kindly check the links. If you have any question, don't hesitate to contact me. Wish you all best of luck. Thank you.